Rahul, can you please tell me what do you understand by electric current?
Yes, why not? Electric current is one when we start switch, the light glows, bulb glows. That we call it as a electric current, sir. Is it not?
What a jerk. Electric current is nothing but flow of electrons from one place to another place due to applied electric potential, or we can say flow of electron when a potential difference is applied between the two ends of a wire.
Sir, do you mean to say that only the wires and not the cables or the rods?
I mean to say not only metallic wires, but we can use metallic strips or metallic rods or any other form of the metal which has the two ends through which we can make the connections.
Sir, what do you understand by potential difference between the two ends?
You see that in your home you use a battery or a cell. A cell has the two ends. One is a positive end and second one is negative end. Positive end of the cell called higher potential side or higher voltage side. Negative end of the cell is called lower potential side or lower voltage side. Difference of voltage values between positive and negative end of a cell is called potential difference.
Sir, at the beginning you said electric current nothing but flow of electrons. What is exactly the electron is, sir?
You see that in nature there are so many elements are there. So many. So these are named as like hydrogen, helium, lithium, beryllium. They are all elements. Carbon, nitrogen, oxygen, sodium, magnesium, silicon, phosphorus, potassium, calcium. All these are elements. They are made up of some very small thing. Take it as a granted. There are very small things which cannot be further divided by any chemical reaction. That is called atom. Atom has further smaller things which keep on revolving in a particular orbit. Like here are the three objects revolving around the central part. The central part is called nucleus. So this revolving or this moving objects are nothing but called electrons. The electrons keep on moving. They are orbiting around the nucleus. They are negatively charged particles. At the center, the proton and neutron are there. And proton and neutron remain at the center only. They do not revolve. They do not orbit. Only electrons are orbiting around the nucleus. Thus, atom has electrons at the center nucleus. Nucleus has two further smaller particles. We call them as the protons and neutrons. Protons and neutrons all together called as nucleons. And electron keep on orbiting around the nucleus. In case of metals, if we provide some energy to the atom, then loosely bound electrons come out of metal atoms and they become free. We call these electrons as free electron. In a given piece of metal, there are crores of atoms, and every atom releases some free electrons. Thus, in a given metal crystal, there are large number of free electrons. At room temperature, these free electrons get some energy from surrounding due to the surrounding temperature, and they acquire some energy, they gain some energy, and with the help of that energy, they move randomly inside the crystal structure. But these electrons cannot escape out of the metal surface. because the energy obtained by these free electrons from the surrounding is not sufficient to escape out of the metal surface. This animation showing the random motion of free electron inside the metal crystal due to thermal agitation.
Sir, you said that these electrons which are moving inside the metal strip due to the thermal agitation, can this electron provide electric current? Can we use them for passing electric current from one point to another point?
Of course, the metals, when they get energy from surrounding, the large number of free electrons are generated. This large number of free electrons can move inside the metal strip due to acquired thermal energy, but they cannot move outside the metal strip because thermal energy not sufficient to make the electrons to go out of the metal strip. To make them to go out of the metal strip and to maintain continuous flow of electrons, we require an electric cell.
Sir, what is an electric cell and what does it contain? Does it contain chemicals or does it contain something else? Please tell me, sir.
An electric cell has two terminals. One is negative terminal, second one is a positive terminal. Negative terminal also called low potential terminal, and positive terminal of the electric cell also called high potential terminal. If we connect a metallic wire between the positive terminal and negative terminal, a potential difference is created between the two ends of the wire and electrons start flowing from negative terminal to positive terminal. Electrons being negatively charged particles, they are attracted towards the positive terminal of the given cell. In this way, the electrical current continuously flow as long as the given cell possesses chemical energy. Daniell cell, Lagrange cell, dry cell are some examples of electric cell. In electric cell, chemical reaction take place and we get electrical energy.
Sir, that implies a chemical cell is one in which some chemicals are present and these chemicals make reaction and we get electrical energy. And whenever chemical reactions are taking place, then only we get electrical current. Am I right, sir?
Yes, you are right. When we connect positive terminal and negative terminal externally by using an electrical wire, then current flows from higher potential side to lower potential side. This is what the function of the cell to provide electric potential and function of the cell to make the electrons to flow from one end of the cell to the other end of the cell externally, such as wires, metallic strip, bar, anything else through which electrons travel, that is a conductor. And we can connect conductor from higher potential side to lower potential side and electrons can easily flow. So that is what the function of a cell is.
Sir, you said electrons flow from negative terminal to positive terminal. Now you are telling current flows from higher potential to lower potential. I am confused, sir. Please elaborate it.
Well, in a given cell, we have the two types of direction. One is the direction along which the electrons are moving. The electrons are flowing. Another one is the direction opposite to the flow of electron. Thus, in a given cell, we study two types of direction. For all practical purposes, we consider the current flowing from positive terminal to negative terminal, that is opposite to the direction of electron flow. The direction opposite to the flow of electron is called conventional direction of current. So here we consider the conventional direction of current for all practical purposes. I repeat, the direction opposite to the flow of electrons is called conventional direction of current. For all practical purposes, the direction of current flow is considered from higher potential to lower potential. I hope you got it.
More the voltage, more the current. Is it true, sir?
Somewhat true, and it is true for metals at a given temperature. If the temperature is maintained constant and resistance maintained constant, then only current increases if the voltage increases. But if the temperature is not remaining constant or the resistance is not remaining constant, then this idea is not valid. This idea is also not valid for semiconductors. I appreciate your question.
Sir, according to you, when the electrons are flowing, we get electrical energy. I understood, sir. But what exactly you understand the flow of electron? When the electrons are flowing, then only we are getting electrical energy, and electrons are not flowing, no electrical energy. So what exactly the electrons have with them so that when they passes through the bulb glows? What exactly happening, sir?
Electron is a charged particle. One electron carries a charge of 1.6 into 10 raised to minus 19 coulombs. Energy of electron depends upon charge and potential difference applied across the two ends. The energy of electron is given by E equals to Q multiplied by V, where E equals to energy in joules, Q equals to charge in coulombs, and V equals to potential difference applied.
Sir, the energy of electron depends upon the two factors as you said. One is a charge on the electron, another is a potential difference. That means the electron travel with the amount of energy E equals to QV. My another question is that when the electrons are flowing, do all the electrons flow with equal velocity or different velocity? How will you calculate the velocity of electrons?
No, all electrons do not have same velocity. For all practical purposes, we do calculate average velocity of electron.
So can I consider that flow of electron is equals to flow of charges, and more the time, more the charges will flow across the circuit. Is it true, sir?
What an idea! Very good. Keep it up. I appreciate your talent. You are on the right track now. Here, electrons are flowing. The flow of electron, nothing but flow of charges. Why? Because electron flow nothing but flow of charges, because electron carry the charge of 1.6 into 10 raised to minus 19 coulombs. So flow of electron is equivalent to flow of charges. More the charges, that means more the electrons are flowing. And the flow of electron with respect to time, that means the time is more the time, more the charges are flowing, less the time, less the charges are flowing.
Can we calculate the charge flowing per unit time, sir?
Yes, we can calculate charge flowing per unit time. We are very close to the definition of current.
Sir, how will you define the current?
Definition of electric current. Suppose Q be the charge flowing through any given cross section of the wire in time t. Then electric current I is given by current equals to charge upon time. Therefore, current I equals to Q upon T. Electric current is measured in terms of ampere. 1 ampere equals to 1 coulomb per 1 second. That is, the 1 coulomb is flowing for 1 second, then it is equivalent to 1 ampere. This is what the definition and the unit of electric current is. I hope you might have understood all the concepts of electric current. If you have liked it, if you understood it, then like my channel and subscribe it and share with your friends, because your appreciation motivates me to produce better quality videos. Wish you all the best. Meet you again with another video. Thank you. All the best. Bye bye. See you again. Meet you again with another video. Till then, wish you good luck.